Okay, I want to redo the mesh for a mock rocket. Okay, so I recreated the geometry. Um, you can see this is my mock rocket, which is the geometry inside here. It looks more realistic than our original, sphere. And I also created two more cylinders. The big cylinder obviously is used to define the overall computational domain. And this smaller cylinder is used to define a subdomain in which we will have refined mesh and unstructured mesh. Okay. The very first step is to create some parts to refer to those different surfaces. So create a part. The first part name, okay, is called. Okay, it's better to. Okay, great. First part name is called innet, which is just this surface. In fact, I also can include this surface. Okay, so both are innets, and then outlet, which should be this surface, and I have to press F9K, then rotate my geometry so that I can see this surface clearly. Then press F9, then select this surface. Okay, you can double check that those surfaces are defined correctly. Okay, inlet, okay, outlet. Okay, great. Then here, this smaller surface is only used to mark the region. It's not a real physical boundary, right? We are not really going to apply any boundary condition here. In fact, we do not know any, physical properties at this inner surface. Okay, I do not know the velocity distribution, pressure distribution, etc. So it's okay to define this whole surface as one single part. So I will call it int surface. Okay, I don't want to call it interface, because if you call it interface after you import this mesh into Fluent, Fluent will automatically treat this surface as so-called interface, okay, which is kind of a special type of boundary. I don't want to cause such a misunderstanding. Okay, then F9, this one, okay, so interface. Okay, then of course here we have the rocket, right? Again, in this case, I only want to, okay, well, to show you, if, for example, okay, I want to know the drag force acting upon this hemisphere head of the rocket and the rest of the rocket body separately, you want to define these two surfaces separately. Okay, so you had that surface, body. Okay, then that surface and this guy. Right. Okay. Then I put them back. Okay, now I don't need the surfaces anymore. I probably only want those curves. Okay, then I will first create a 3D block, and its part name should not be solid. Okay, instead it should be fluid. Because if you call it solid, then after you import the mesh into Fluent automatically assign a solid material to this whole domain, which probably is not what we want. Then apply. Okay, then we do some association, some preliminary association. Remember to check this box here. Then select all these 4 edges by using a box, or alternatively you can simply click these 4 edges. Okay, that's also fine. Then press the middle button, then press this curve middle button. Okay, then the association is done for these 4 edges. Okay, then these 4 middle button, this curve middle button. Okay, pretty much that's good enough. Then I will cut my block. I first use the O-grid, select the block, which is the only block I have. Then select the surfaces. I have to select these 2 surfaces, then apply. Then my block is now split into 5 blocks. Okay, 1, 2, 3, 4, 5. Okay, then I do another cutting. Okay, I first cut here. Then I cut here, I believe. Okay. Then I will delete this block. Okay, because that block will not have structure mesh. It will have unstructured mesh. So here I first right-click blocking, then click index control to turn on the index control of the blocks, and I increase that. I see all those blocks at the very center. Then I delete block, this guy. Okay, it's deleted. Then I do a little bit association here. Say this 4 should be associated to this guy. Okay, and this 4 to that guy. Okay, let me see if that is going to work. I hope that is going to work. If it doesn't work, then what? Okay, let me try that. Okay, maximum size, say 1, display. Okay, pretty big. This big, that's fine. Blocking, parameters apply. So 4,000 something. Seems okay. Okay, then go back to blocking, turn on pre-mesh, see how it looks like. Okay, I really want to know if that part is correct. Okay, not correct. Okay, so that's a problem. That's a problem. That's fine. I know how to do that. Or do I? Okay. First, I delete all the blocks. Okay, I will redo my blocking fluid. Okay, apply. Replace. Okay. I do the association. Okay. I do the O-grid. Okay, then I do the cut. Okay, I will directly create my mesh, pre-mesh. Okay. Oh, now I know why it doesn't work very well. Okay. Anyways, yeah. So it's not really because I made a big mistake there. That's because I will need to create another O-grid for this smaller cylinder. So that's what I'm going to do. Again, I will turn on the index control, then O-grid. Let me say blocks. Probably here I directly select the surfaces. That should be well, also this guy. Okay. Then apply. Okay. And more O-grid here. Then I will delete my blocks. Let me see this one. Okay, so all those blocks will be deleted. Okay, and reset. Okay, you can see the other remaining blocks down here. Okay, let me see if I can finish this tutorial before 10 o'clock, because when the chapel begins. Okay. Turn on the pre-mesh. Okay, obviously it's not super good. So here you will want to change the edge density. Right now you have 4 here. You have how many? Just 2. That's too small. Okay. Here's 6. Okay, I'm not saying 6 is the optimal number. Okay, I'm just saying that right now this is what I'm doing. Okay, say check copy parameters, apply, and turn on pre-mesh. See how it looks like now. Okay, a little bit better. Not so bad, so good. Probably because I forgot to do association here. Okay, this is what I'm going to do. Okay, this is what I'm going to do. Associate this guy, this guy, this guy, and that guy to this, and do the same thing here. This guy, this guy, this guy, and this guy. That. Okay. Reset. Well, since it seems that I have to use this index control a lot, so I will keep it here. Then go back here, apply. Did I just push apply? That's probably not the right thing to do, because I reset this edge. Did I reset it? Okay, let me see. Yeah, it should be 6, right? Okay, good. Then this one right now is 5. Let me use 10. Okay, so how about this longer 115? This one is 3. Let's use 5. How about this one? 7. Let's use 10. Okay. Again, don't think those numbers I put here are the optimal parameters. Okay. I didn't say that. In fact, you have to do some numerical experiments to really find out if the mesh is fine enough. Okay, the structure mesh has already been ready. Okay, in the region in between this smaller cylinder and the big cylinder. Then I will create an unstructured mesh. You probably have already known how to do that. You first create a so-called body. Okay, body. Go back to geometry, then body, the part. Well, fluid 2. Okay. I don't know if you still call it fluid or what will happen, but let's be conservative. Then select this point and this point. Just make sure that this material point, this body point, is totally enclosed in the region where we want to have unstructured mesh. Okay, then we create the mesh. Okay, before we do that, let's first change the mesh setting. You know, we want a little bit refined mesh, right, in this inner region. So I'm going to change the maximum size for the inner surface from 1 to maybe 0.3, suppose. Okay, and the ratio probably 1.2, and the rocket body, rocket head, the minimum size will be even smaller, 0.1, 0.1. I don't know if I should set the numbers here, okay, but I don't know. Okay, I also want prisms here, and prisms number of layers 6. Okay, 6, and I think it should be here. Okay, let's apply. If it is here, maximum size, height. Okay, it's pretty much the same, right? Maximum size and height. Layers. Okay. Let me first do some experiment. Okay, 0.05. Okay. Then compute. Oh, wait a minute. Here I should check this box. Okay, create prism layers. Okay, forgot that again. Okay, create prism layers to save the current geometry. Yes. Okay, it asks me to save it. Okay, project 2. I don't know. Okay, I will do it again. Okay. No one knows what it is doing. Prism finished. Really? Okay. I don't really trust that the prism is finished, because if I use a cut plane, you probably can see that the prism maybe not finished. Right, I do not see that. So I think I have to recompute. Replace that. Okay. Okay. Okay, I will see the cut plane, show cut plane, then also show the volumes. Now you can see the prism there, you know, right? It has, you know, these 6 layers, 1, 2, 3, 4, 5, 6. Not 100% sure if it is according to 0.1 or 0.05. It seems that I forgot to put the number here. So let's see how it looks like. How should I do that? Okay. Well, this side in fact is pretty good. Okay. Anyways, do some experiments. Okay. See how it looks like. Okay. Now I have 2 mesh. Right. One mesh for the central part and one mesh for the outer part. So I want to combine these 2 mesh. So I will first convert this pre-mesh to unstructured mesh, then merge these 2 sets of mesh. Okay, merge. Okay. Man. Now you can see this whole mesh thing. Then I will edit my mesh. Make sure that they are the same on the intersurface. Accept, apply. Okay, so there are some changes. Okay, at the surface. Dismiss. Okay. You can see now the mesh at the interface becomes pretty like a structural mesh, right? But in fact, it's still unstructured mesh. Okay, I saved my project. Project 3. Okay, whatever. Okay, then I go to output mesh, ANSYS Fluent, apply. No. There's one more thing I have to do. Okay, go to this BC, boundary conditions. Find that intersurface. Okay, this guy, create new boundary condition. It should be an interior surface. Okay, it's not a real physical boundary. It's just the interior of your domain. So okay, then accept, then save your project, then okay, whatever. And the 3D Fluent Rocket, and done. Okay, done with translation. Okay, so the mesh is done. So this is the end of our tutorial.